The asset age ratios below may be useful to analysts. You need to know these formulas. The first thing to note regarding these three formulas is that the denominator in the formula is annual depreciation expense. In order to remember this formula, I will paint a simple scenario. Imagine at time t equals to 0, a non-current asset was purchased for 10 million US dollars and it has useful life of, let's say, 10 years. Let us also assume that the salvage value, which is also known as scrap value of the asset, is 0. The salvage value could also be called the residual value. Let us also assume that today is the end of year 6. If today is the end of year 6, that implies that the remaining useful life of the asset will be 4 years. That also implies that the average age of the asset on this day would be 6 years. It also implies that the accumulated depreciation on this day would be 6 million US dollars. Why is that so? It is so because the annual depreciation expense is the historical cost, which is 10 million minus salvage value all over the useful life of the asset, which is 10 years. That implies that the depreciation is 1 million US dollars on an annual basis. So the accumulated depreciation at the end of year 6 will be 6 million. On this day, the net PPE, which is the historical cost less the accumulated depreciation, would be 4 million. So let's get started with how to remember the first formula. When it comes to the first, which is the average age of the assets at the end of the 6th year, the average age of the asset is 6 years. 6 years will be equals to x all over the annual depreciation, since we agreed that the annual depreciation for all the denominator for all the three formulas is annual depreciation. So the annual depreciation from our calculation is 1 million. If we are to solve for x, x would be 6 million. 6 million divided by 1 million is 6. So what is 6 million in the scenario I painted? 6 million is accumulated depreciation. That implies that the average age of a non-current asset is accumulated depreciation all over the annual depreciation expense. Moving on to the second formula, what is the total useful life of this non-current asset from the scenario I painted? The total useful life is 10 years. That's 10 is equals to x all over the annual depreciation expense, since we agreed that the denominator for all the three formulas is annual depreciation expense. and the annual depreciation expense is 1 million. Solving for x would be 10 million. So what is 10 million in this scenario I painted? 10 million is the historical cost. That implies that the total useful life of the non-current asset is the historical cost divided by the annual depreciation expense. Please note, historical cost is also known as a gross cost or the gross PPE. Moving on to the third formula, which is remaining useful life of the non-current asset. The remaining useful life of the non-current assets at the end of year 6, based on the scenario I painted, will be 4 years. 4 years is equals to x all over the annual depreciation expense of 1 million. If we solve for x should be 4 million, because 4 million divided by 1 million is 4 years. So what is 4 million? In the scenario I painted, 4 million is the net PPE. The net PPE is the gross PPE less accumulated depreciation. So you will agree with me that the remaining useful life of non-current assets is net PPE divided by annual depreciation expense. So we should agree with this. All of the three formulas have the denominator as annual depreciation expense. The gross PPE is the same as the historical cost or gross cost. It is also worth noting that the net PPE is the gross PPE less accumulated depreciation. What do we need this for? Older assets with shorter remaining useful lives indicates a greater need for a company to reinvest in productive capacity. If an analyst assesses the assets of a company and based on this calculation, the assets are older assets and the assets have shorter remaining useful life, then that indicates that a greater need is required by the firm that owns such assets to reinvest in productive capacity, because it implies that very soon these older assets will exhaust the remaining useful life of the assets. High capital expenditure in relation to what the depreciation expense is suggests active replacement or expansion of PPE.